Let's talk about one of the most stubborn, distracting problems in video games, one that's been around for decades. I'm talking about ugly shadows. And more importantly, we're going to dive into the incredible Unreal Engine tech that's finally fixing it for good.
Oh, you know exactly what I'm talking about, right? You're exploring some gorgeous open world, and then you see it. That sharp, visible line on the ground where blurry shadows just instantly snap into focus. It completely rips you out of the experience. Well, that little immersion-breaking trick is on its way out. Really, what we're looking at here is a shift from a system of constant, ugly compromise to a genuinely elegant solution. On the left, you've got the old way, all those visible seams and jarring changes in detail. And on the right, that's the new way, virtual shadow maps. The promise is simple: consistent, film-quality detail no matter how near or far you are. This isn't just a minor upgrade, it's a total rethink of how game worlds are lit.
So, how did we get stuck with those ugly shadows for so long? To really get why the new solution is so brilliant, we first have to understand why this has been such a massive headache for developers for like 20 years.
Okay, so the main culprit behind that awful pop-in effect actually has a name: Cascaded Shadow Maps. You'll hear people call them CSMs. For the longest time, this was pretty much the only tool developers had for creating dynamic shadows in these big open environments.
So here's how this old method works. It basically slices the world up in front of you into a few different zones, or cascades. Think of them like invisible boxes. The box closest to you gets a high-res shadow map, the next one gets a medium-res one, the one after that gets a low-res one. You get the idea. The problem is that hard, visible border, or one box ends and the next one begins. That's the cascade line you see on the ground. And it has been the bane of immersion for a whole generation of gamers.
Okay, so if chopping the world into these crude, clumsy zones is the problem, what's the solution? Well, the answer comes from a really brilliant conceptual leap. It's all about virtualization. The engineers over at Epic Games got inspired by some other game-changing tech. You know, if you remember megatextures from back in the day, or more recently, Unreal's own Nanite system that lets them use movie-quality models, you'll get this right away. Virtual shadow maps just apply that same core idea: hey, what if we didn't have to load everything all at once, but for shadows? And it breaks down into this really elegant three-step process. First, the system just pretends it has one single gigantic, impossibly detailed shadow map for the whole scene. Then, it breaks that imaginary map down into thousands of tiny, manageable little squares called pages. And then, and this is the magic part, the engine only renders and loads the specific pages it needs for the pixels that you can actually see on your screen in that exact moment. No more crude zones, just pure efficiency. And when I say gigantic, I am not kidding. The virtual resolution of one of these shadow maps is a staggering 16,000 by 16,000 pixels. I mean, to put that into perspective, that's 4 times the horizontal resolution of a 4K TV. That's the kind of insane detail you need to cast a clean shadow from today's super high poly models.
But here's the genius of this system. That massive 16K map gets broken down into these tiny little 128 by 128 pixel pages. So by only dealing with the tiny pages it needs at any given time, the engine gets the final quality of that giant map without the absolutely impossible performance cost. It's truly the best of both worlds. Okay, but here's the thing. Having perfectly sharp, crisp shadows everywhere, that doesn't actually look realistic. So the next big challenge was to take these hyper-detailed shadows and make them look soft and physically believable. You know, like they do in the real world. Exactly. If you just use that giant virtual map as is, you'd end up with these razor-sharp shadows everywhere, and it would look just as fake as the old blurry ones. In the real world, shadows have softness. They get more diffuse and blurry the farther they get from the object that's casting them. To solve this, Epic came up with another super clever piece of tech: shadow map ray tracing, or SMRT for short. Now, this isn't full-blown, performance-heavy ray tracing. Instead, it's a smart shortcut. For each pixel on screen, it just fires a few sample rays towards the light source and checks them against that high-res virtual shadow map. And this lets it create beautiful, variable softness and this really important effect called contact hardening. That's where a shadow is sharp right where it touches an object, but gets progressively softer as it stretches away. And trust me, the difference is night and day. The old method, PCF, was basically just a big, dumb blur filter. Sure, it made shadows soft, but it also destroyed all the fine detail. SMRT, on the other hand, gives us that physically plausible softness that changes with distance, that beautiful contact hardening, all while preserving every single bit of detail from the high-res map. So let's put it all together.
We've got a system for insane resolution and another for making it look soft and real. When you combine them, you finally get the big payoff for both the developers and for us, the players.
So what does all this tech jargon actually mean for you when you're playing a game? It means that for the first time ever, shadows just look correct. They're no longer a distraction. You can be miles away from a building, walk right up to it, and its shadow will look consistently high quality and realistic the entire time. No more pop-in, no more ugly seams. And honestly, this quote from the graphics experts at Digital Foundry just nails it. This tech gets rid of a harsh, distracting visual bug that we have all just learned to live with for 2 decades. And now, it's just gone. And what's really crucial to understand is that virtual shadow maps don't just replace the old CSMs. They actually replace a whole messy toolbox of different, complicated shadow techniques that developers used to have to juggle. It just simplifies everything, creating one single high-quality pipeline that just works. But of course, no technology is a perfect silver bullet for every single situation. So to get the full picture, we've got to look at where virtual shadow maps really shine, and also where they still have a few challenges. So what are VSMs amazing at? They are absolutely phenomenal for the main sunlight in huge open worlds, especially when you're using Nanite's detailed geometry. But they can struggle a bit with more complex light shapes, like a big rectangular area light where the light source itself has a size and shape. For those kinds of lights, or scenes with tons of small local lights, full-on ray tracing can sometimes still give you a cleaner, better result. So even with a few specific limitations, it is crystal clear that virtual shadow maps are the new foundational standard for real-time graphics. Let's just quickly recap why. When you look at Epic's own goals for this tech, it tells the whole story. They wanted to match the insane detail of Nanite. Check. They wanted realistic, soft shadows that didn't destroy performance. Check. They wanted a simple, it-just-works solution for developers. Check. And they wanted to unify a bunch of old, clunky systems into one. Big check. It's a massive success across the board. And this all feeds into the much bigger picture. VSMs aren't some isolated feature. They are a core pillar of what makes Unreal Engine 5 so special. They work hand in hand with Nanite for virtualized geometry and Lumen for dynamic global illumination to create these massive, fully dynamic, just absolutely breathtaking worlds that were literally impossible to make before. You know, it really says something about how fast graphics are progressing. For 20 years, our eyes were trained to see that ugly cascade line. Now that it's solved, a whole new level of realism is just standard. Which leaves us with a fun little question to think about. What's the next subtle graphical flaw that we're all going to start obsessing over? Makes you wonder what's next on the list.